Hey everyone, good afternoon. For those coming in, lots of seats kind of all over the place. So come on in and get cozy and say hi to your neighbor. We're going to kick off here just because I have a whole lot of stuff to talk about and only 50 minutes to talk about it. So this session is Serverless Architecture Patterns and Best Practices. My name is Chris Munns. I am a Senior Developer Advocate for Serverless from Amazon Web Services based in New York City. Really excited to be out here in Belgium this week, my first time out in this country. So thank you all for having me, and again, thanks for coming to this session. Background-wise, so I've got some of the other roles that I've had in my career up there, but I'm primarily an operations guy. I've spent a lot of time in data centers, spent a lot of time managing Linux servers, wiring things, doing infrastructure automation, running databases and stuff like that. And within the last kind of year and a half, I realized that basically the entire first 15 or so years of my career were coming to an end in the future, and the way that this world is going is towards this thing that we're all calling serverless. And so here this week there's been about a little over half a dozen talks that have the name serverless in the title. Probably many more that had serverless or talking about serverless technologies inside of them. So this is a really exciting space. And so in today's talk, I'm going to be talking primarily about AWS's services around AWS Lambda. So fully upfront, if you were thinking of hearing about other serverless technologies, I will be pretty heavily AWS focused. Totally cool if you want to leave because of that. But you've got fair warning that that's going to be the space that I'm in. We're going to talk about a whole bunch of different things, and I'm going to constantly try to bring it back to best practices. So as a developer advocate, what I do is spend a lot of time connecting with folks like yourself in settings like this, and in one-on-one and on Twitter and in Slack and stuff like that, talking about best practices, how to build serverless applications. Something else to get out of the way. Yes, there are still servers behind serverless. We don't have some magical thing that Jeff Bezos popped out of his brain that we run compute code on that is completely unique to us. But that's not the point. And so the term serverless, as it's been a little bit abused in the industry by various different vendors and providers and folks, so we have at AWS is a pretty standard, what I think, definition. And actually, I got a chance to see Brett and I believe Guy's talk a little earlier today when talking about serverless. And so at least us and Google and Microsoft and a couple others have kind of aligned around kind of the same kind of points for what serverless is. So for us here at AWS, it means no servers to provision or manage. So absolutely no managing of an operating system, no need to patch management, anything, no need to log in over SSH or RDP or anything like that. This includes no management of containers. So this is not similar to a Kubernetes or a Docker or a Mesosphere or ECS or anything like that. Should scale with usage. So requests come in, requests get answered, whatever in this case for your application request is. It's something that you shouldn't have to think about ahead of time how many requests you might get at any point in time. And that aligns very much with the next bullet point, which is never pay for idle. And so ideally with a serverless platform, you're never paying for idle, right? If you're not getting traffic, you're not paying for something. And typically when organizations think about capacity planning, what they're doing is saying, how much are we willing to spend in hopes that we get traffic to not be denied because we didn't spend enough, but also we're not paying for too much idle. And across the industry, they say typically for IT organizations, most server fleets sit at less than 20% utilized. So it means that you're spending your money on 80+% of idle. And so with serverless technology, is no cost in paying for idle. Things will kind of be fired up and created as you need. And then lastly, availability and fault tolerance built in. So here at AWS, we have this model of regions. There's about 16 or so of these today around the globe, I believe. Regions have inside of them availability zones. These are kind of, you can think of them as independent data centers, sometimes clusters of data centers. Where in typical high availability architecture patterns for AWS, you're thinking about having resources in at least 2 or more of those availability zones so that you could potentially deal with any one of those going away. In the case of serverless, this isn't something that you should ever have to think about. There's no real need to comprehend or think about availability zones. So at AWS, kind of the core of the world of serverless is AWS Lambda. Logo, it's kind of right here in the middle of these slides. And for a serverless application, what you have is some sort of an event source, something that maybe is reacting to changes in data state, requests to endpoints, changes in resource state, that's going to invoke a Lambda function. So for those who are not familiar, basically what Lambda is behind the scenes here at AWS, we run a very large amount of compute infrastructure. When a invocation comes in from an event source to your configured Lambda function, we go and grab one of those compute resources for you, basically say it's yours for your account, take your code, pull it down onto that host, execute that code for you, whatever it does. Maybe it talks to other databases or services or just has all its own business logic constrained. And then completes what it needs to do. And so you only pay, in the case of Lambda, in the hundreds of milliseconds of time. Many customers' Lambda functions take way less than 100 milliseconds worth of time. And so it's kind of the smallest amount of compute that you could ever think existing or paying for, again, without you managing any of the underlying resources that are part of it. There's a number of different use cases for this today. So I'm very lucky to have 3 of my close peers here, Randall, Xray, and Tara, who all gave talks earlier today. So you might see some of the same content that they had as well, talking about various different use cases for serverless. So things like web applications and backends, kind of pretty standard stuff. So we see a lot of companies moving from standard kind of 3-tier web architectures to serverless architectures with things like single page applications or native mobile applications, then powered by serverless backends. Data processing, so whether it be stream processing, batch processing, things like doing MapReduce. There's a number of really kind of cool scientific libraries built on top of Lambda. Actually kind of, I would say, dollar for dollar if I was in the States, I'll say euro for euro. Kind of one of the biggest use cases of serverless today actually is data processing. Chatbots, Amazon Alexa, and then lastly, IT automation, which is a lot of people's kind of stepping stone into the world of serverless and Lambda, traditionally also from like the operations role. Now, in terms of how you work with Lambda, again, I mentioned there's this invocation model, so something has to trigger a Lambda function, and today there are 3 different models for how this works. There is a synchronous model, so a push-based model. In this case, the example of API gateway, I'm going to make a request to the order API. That's going to invoke a Lambda function that's going to hopefully very quickly return whatever it is that the order API is supposed to return, and onward I go. In the synchronous model, you see examples like SNS and S3, where what's different here is I'm going to put some sort of a message or an object into either SNS or S3, and then at some point Lambda is going to do something. Now typically this is very quick, but from a user's perspective or from an infrastructure perspective, you put your message or your object into those services, you get back a 200 or everything's okay, and then maybe you go later on and you check to see what happened or what the result was of that activity. So you don't care about a synchronous reaction from Lambda. In this case, it's just an asynchronous invocation. And then lastly, with DynamoDB and Kinesis, what you see here is the stream-based model. So in this case, and actually with DynamoDB, it's using Kinesis under the hood, requests are being streamed across the fire hose of Kinesis, or the stream of Kinesis, I should say. And what's going to happen is that's going to help invoke Lambda functions behind the scenes. They're going to pull objects basically out of the Kinesis stream and do whatever they need to do with that. So we see a lot of people using this for real-time analytics, IoT sensor data processing, doing things like replication of DynamoDB tables, doing things almost kind of like triggered functions off of DynamoDB actions, a lot of kind of interesting things there. And today there's actually a little bit close to about 30 different services that can invoke Lambda. So lots of different ways to glue together inside of your architecture and make things go. So that's kind of the quick overview of what Lambda is if you haven't seen it before. Now I'm going to start to get back into kind of some of the other aspects of this talk. Bless you. So real quick, where do you start? And so I'll cover this here for folks who actually have never started in this space before. And the answer is find a framework. So there are close to about a dozen or so pretty mainstream frameworks that we see out there today. These are some of the most popular of all of those. So there are, again, quite a number of tools out there, many dozens of them actually. Apex, something called Chalice, which we actually released from a completely different part of AWS, unrelated to Lambda and API Gateway. Claudia.js, Serverless, Sparta, and Zappa. And so with all of these frameworks, what they're going to do is they're going to simplify what's necessary for you to build and launch a serverless application. So again, you've got an event source, you've got your Lambda function, it does something. They're going to help you glue together that entire process so it's that much easier. So as an example of this, with Claudia.js, what it basically takes is, let me see if I can make this thing work here. Yes. Basically it takes about 5 lines of code to get an API. So you have here, you basically are including the package. We're going to then create a new version of this class here. We're going to export a module, and then we've got a very basic kind of handler for return hello world. Really, really basic example, but given these 5 lines of code and then the command line that's all the way at the bottom here, Claudia create, that's going to give me a Lambda function, an API gateway, and all of the IAM permissions glued together to make this API endpoint exist. So really, there's no easier way to get started creating APIs than an example like this. Again, so this is Claudia.js, Node.js framework. On the Python side of things, we have AWS Chalice. And so it's kind of an interesting story. The AWS SDKs and APIs team, people who own things like Boto and our various SDKs and frameworks, were doing more and more with Lambda and Serverless. And they were looking for easier ways to create APIs for themselves. And they happen to be a very heavy Python organization. And so a couple of developers on the team one weekend started hacking together, put together this tool, and they were like, oh, wow, this is actually pretty awesome. Open sourced it, and now it has a really, really robust open source community. So very similarly to what we saw with Claudia.js, again, it's about 5-6 lines of actual code here, and we get an API endpoint. So really, really, really easy to get started if you are completely new to this space. So again, the frameworks are really awesome, but some of them are maybe a little more opinionated. They actually interact with how you write your code. But maybe you're coming from the world where you've got existing code, or you're really strong in a language that's not supported by one of these tools. So where can you start in that case? In this case, this is where we have something called WSSam. And so Sam here, our wonderful little squirrel mascot, you'll see it pretty much all over the place now in regards to what we're doing with serverless. This is the official mascot of serverless for AWS. And you'll see it on things like on socks, which I have my Sam socks on today. Randall gave some out earlier, and we've got lots of stickers as well. And so what SAM is, actually stands for Serverless Application Models. This is actually a framework that is built on top of CloudFormation that makes it really easy for you to deploy serverless applications. So again, kind of gluing together things like Lambda functions and APIs and DynamoDB tables. So if we were to think about what's required for deploying a Lambda application with CloudFormation, we're looking at a whole bunch of code here. And I'm not going to attempt to make you read this YAML, but it's about 80 or so lines of code. And so that's no fun to write. Nobody really wants to write 80 lines of YAML to deploy something. And so SAM, really, really straightforward. It's actually about 20 lines of code. The way that this breaks down is the first couple lines are the headers of the template. The second line there is kind of key. It's called a transform. It's a capability of CloudFormation. Then what we have are resources. So we have a get function resource and then a list table resource. And then inside of the function resource, we see properties for Lambda and then events. And so inside of events, this is actually going to relate back to things like API Gateway and Kinesis and S3 buckets, SNS, Alexa, stuff like that. And so in events there, we have type API. We've got some properties around the path and the method. And so what's going to come out of this template is a Lambda function, an API Gateway, DynamoDB table, and all the permissions basically to glue together the access for the API Gateway to invoke Lambda, Lambda to talk to Dynamo. Again, just in about 20 or so lines of code. Another way to think about this from a visual sense, and this is using CloudFormation's designer to visualize it, is we've got a sample over here. And my apologies, I lost the text for the link to the URL for this code. But basically from lines 9 to 25, what it creates are roughly about 6 different resources. And again, otherwise you'd be doing this manually in the console or typing out much larger CloudFormation templates. With SAM, you've got 2 commands, a package and a deploy. Pretty straightforward. Package is going to actually zip up your files, put them up in S3 for you. Deploy is then going to take those packaged up files and deploy them for you in the live environment. And then real quickly also about this, so just a couple months ago, we launched something called SAM Local. If you haven't had a chance to see this, definitely encourage you to take a look and take a spin on it. So what SAM Local does is it actually uses Docker local on your laptop to wrap up your Lambda function and make it available for you locally on your development environment. So it gives the ability to basically create a mock API interface. You can also do invocation test calls, similar to how you do it with Kinesis or Dynamo or S3. And it's got a bunch of really cool things to do that. It's actually written in Go. It's open source. We've got a lot of community activity here as well. So take a look at this and check it out. If you were looking at some of the other frameworks that exist, though, quite a number of them actually do also support local testing now. So about 6 months ago, we used to hear in the community all the time, oh, local testing is so hard, impossible, how do you do it? In that 6 months, about half of the frameworks that are really popular now have local testing, including SAM. Some of them are actually built on SAM. And so this is an incredibly rapidly evolving space when it comes to all the various aspects of building and running applications in it. Excuse me. Cool. So let's talk about kind of the next section here of building and running a serverless application. So building and deploying your application. So we talked a little bit about what you could do with SAM itself, but there's kind of a number of other parts of the family that fit into this. So the first I'll talk about here is code build. Effectively, this is our build and test tool at AWS from the development tools perspective. Completely managed, pay by the minute of usage of it, and useful for everything from compiling code to doing linting and syntax checking to doing unit tests to eventually deploying your code potentially. And the way the code build works is it has something called a build spec file. You can actually put this text file into your code repository, or you can configure the service to use it via its APIs or the console. And what this does is really pretty straightforward. If you use kind of any of the other really popular hosted CI tools like Travis CI or Circle CI or Code Build, you've seen things pretty similar to this. If you've done any of the kind of Jenkins 2.0 stuff, you've seen stuff similar to this. So just kind of an example of what you would do with Code Build. But I've got some environment variables, and then we've got 4 phases. And basically, phases are sequential grouped areas where I can run commands. You can think a little bit of Code Build as kind of a glorified shell script execution engine, although that definitely doesn't give it enough credit for what it does. And so I'm going to do an npm install my Node.js modules. I'm going to run ESLint to lint and check the syntax of my scripts. I'm going to run npm test to run unit tests, and then I'll use the CloudFormation package command to package up my code around my SAM template and send it on its way. So that's Code Build. Next up we have is Code Pipeline. So Code Pipeline is kind of the sibling service to Code Build. It's a continuous delivery tool. Again, similar to what you would see in tools such as TeamCity or what you can do in Jenkins with pipelines, and a number of other tools out there these days. And basically what it does is it allows you to first visualize and then very easily construct what's considered a pipeline, effectively your application lifecycle. So we see here a very basic example for a developer where I have my source repository. I then pass that on to a build stage, and then I have my deploy where I'm using CloudFormation to actually do the deploy of what I'm doing. In this example, I'm going to run some stubs, unit tests, or integration tests. You could think of it using Lambda. And there's a lot of different capabilities in Code Pipeline that makes this all possible for you. But if you're completely new to the space, you're starting out completely fresh, don't have any of these tools, I would definitely say start with these. Again, they're all pretty much pay for what you use products, and so pretty painless to get going, and always good practice to build CI and CD into your development as soon as you can. So talking a little bit more here about Lambda. So Lambda has a concept of environment variables. If you are familiar with things like Heroku's or the 12-factor practices, they talk a lot about storing configuration information in environment variables, not putting it into your code. Not putting it even into a database potentially. And so with Lambda, you have the ability to pass in key value pair configuration environment variables, if you will, which are then made available to you basically via the runtime environment from Lambda. So you pull them into your code the same way that you would pull in, say, an environment variable from the Linux OS. So the same commands in those the languages that you use, such as the process.env or os.environ for Python, can be used to grab these. Now you can also use KMS, which is our key management service, to encrypt these. So that's useful for API keys, database credentials, really credentials of any sort or type. And so these are really useful for creating individual environments. And we're going to spend a little bit of time here talking about how you think about environments with serverless. So API Gateway supports something pretty similar. In this case, they're called stage variables. Stage variables also these key value pairs that you can configure. And then they are made accessible via a number of different fields inside of API Gateway requests, depending on how you have your API Gateway configured. Cool. So how does this tie into SAM? So going back to SAM real quick here, on the left-hand side of the screen, we have parameters that we'd pass in. And this is pretty standard syntax for CloudFormation. And so we see that I have 2 parameters, my environment and then special feature 1. And my environment has allowed values of testing, staging, and prod. Special features has allowed values of true and false. Maybe it's a feature flag for something I'm testing. And then I actually go and pull those into my Lambda function and API Gateway definitions over here on the right. And so pretty easily with my Lambda, my SAM template, I could accept different values from whoever's using it, pass those into my Lambda function, and then inside of my Lambda function consume those. And maybe my function behaves differently, or there's slightly different logic that's inside of it. And this is a great way to pass that in dynamically through that. Now, I had mentioned that it's considered not necessarily a great practice to pull in configuration environment variables from databases. That said, there's kind of an explosion in the number of services that do this today via different ways. So there's people who use console, there's people who use things like etcd. We also have another service called System Parameter Store, which is part of Systems Manager, which actually can do this as well for you. So with Parameter Store, you have the ability to store key value pairs in a hierarchy. You can encrypt them. You can really tightly control who has access to them. It's centralized. And then so if you're in an enterprise where you can't just give out keys to developers and allow them to access it wherever, Parameter Store is probably one of the best tools from an enterprise perspective for allowing your code to be highly dynamic and to, at runtime, get access to the variables that you need. So you see an example of this here in some Lambda code. Basically, I initiate the client using Boto. I then define the parameters that I want to get. I pull it in, and then later on I can use that value inside of it. So really useful for configuration parameters, feature flags, database credentials, API keys, stuff like that. So if we put a bunch of this stuff together here, so we have again this concept of stage variables. We have separate what are called stages inside of Lambda, inside of API Gateway. We also have versions and aliases in Lambda. What you can actually do when combining the two of these is kind of very easily create these different environments inside of your account. So you've got dev, beta prod, or dev staging prod, whatever you want to call them. And so this is one way for you to control multiple versions of your code kind of across the life cycle of how you develop it. That said, there is some back and forth on the thoughts of whether you want to have everything inside of a single stack or things inside of multiple stacks. And so a lot of this comes down to personal preference, comes down to team size, it comes down to kind of governance inside your organization. So again, you have here the options for having a completely kind of single stack of resources where you've got your testing, staging, production environments, all kind of managed by a single template. You could also then do something which is multi-stack, where instead of having all those things inside of a single stack, you have basically reusable templates potentially that allow you to stamp those out repeatedly and then leverage kind of the dynamic capabilities of SAM or CloudFormation, environment variables, and so forth to make it a little bit easier. So typically we see enterprises, people that are running things a little larger in scale, use the latter. But if you're smaller and you're getting started and you have a smaller team, the first will make sense for you. Now this actually aligns pretty well with how people think about doing their AWS accounts. So interestingly enough, AWS accounts are a unit of control and scale. You may not think of it that way, but actually what we see is many large enterprises will have hundreds, if not thousands, of accounts. And even now we're seeing a lot of smaller teams try to do this where they'll separate out dev, staging, and prod into different AWS accounts. And so a number of kind of pros and cons that come with this around, it's obviously a lot easier to manage single accounts versus multiple accounts. Easier also from a management tool perspective. So let's say you're using a product like a Datadog or a Loggly. Well, having multiple accounts listed is a lot more complicated in those products than having a single account. So that's something you have to think about. However, when it comes down to permissions and access separation, which many organizations do care about, a single account model is just not going to work for you. And so that's when you're coming and thinking again about multiple accounts and kind of leveraging tools that help support that. And so we have a product called AWS Organizations that came out, I think, earlier this year technically, which helps make this a lot easier for you to manage multiple accounts kind of under an umbrella account structure. So my personal advice and the guidance that I like to encourage everybody, don't do the mega single stack thing. There's a number of things that become really complex when you do that in terms of management of resources. Also, there's maximum size limits to templates, and so that can be a little bit of a pain. You do want to leverage the dynamicness of parameters and mappings inside of SAM so that you don't hard-code values. Right? So you really want to get away from any sort of hard-coded value inside of Lambda, inside of your SAM templates, anywhere else. You can make use of things like export and import value, or what's called cross-stack references in SAM. So this means that you could have a stack where you launch your database resources, and you can have a stack where your serverless stack resources are launched, and you could basically point one at the other without having to launch them all as part of the same stack. Again, really helps from kind of a separation of roles and responsibilities. And lastly, again, build out multiple environments for development and test and so forth. Ideally using the same template, even across environments. Don't do it different ways in different environments. That's one kind of common mistake that people will make, where production doesn't look like dev or staging. That's typically where a lot of issues come from. With Code Pipeline and CloudFormation, there's actually kind of two different ways you can make this really easy. So in Code Pipeline, you can pass in a template creation file, or you could actually hard code in the pipeline the variables that you want to pass in. And so if we put this all together in terms of Code Pipeline, what you can pretty easily get here is a pretty straightforward multi-stage pipeline where we've got a development, a staging, and a production, or in this case, sorry, a testing, a staging, and a production stack. They could all use the same template. You can make use of environment variables and dynamicness to pass this all in, even across different accounts, and kind of get all the nice kind of controls and stuff that you want. And definitely this is the type of model you want to follow regardless of what your CI and CD tooling is. Now, all of this aside, we just a couple of weeks ago at Serverless Conf New York City announced that we will shortly here be launching something called traffic shifting in Lambda aliases. And so what this will allow you to do is assign a weight to a Lambda alias, such that what we will do behind the scenes from your invocation source is shift traffic towards your second version given the weight that it has. So you can just think of it as pretty much a weighted alias. The way that it looks from the CLI is I have a function, I've updated it, I'm going to publish a version, and then I'm going to assign an alias and I'm going to give it 5% of traffic. And so we will, again, behind the scenes, direct that 5% of traffic. You don't have to handle that from, say, an API gateway or Kinesis or any other sort of invocation source. You'll see separate graphs, separate logs for those different versions. And then you can very easily automate out, okay, I got 5% up. It looks good for some period of time. Now I'm going to shift that all over to 100%, tear down my old version, and away you go. And so that's going to change the story that I just told you a little bit here. But as of today, you want to think of multiple stages for environments and having them all kind of broken out. Cool. So given all of this, I often like to say that you can't move fast if you can't measure what's going on. I previously used to represent all of the DevOps products that AWS has, all the management tools and developer tools. And what I used to find was that basically 9 out of 10 organizations really underinvested in monitoring, logging, metrics collection, and application profiling. And there are 4 areas where basically every dollar you invest is going to give you some multiple back into your business. And so you really want to think about what you're doing from a visualization and measurement standpoint. For serverless, what we have is CloudWatch built in across a number of different levels. And so we like to say that monitoring and logging are universal rights inside of serverless applications. So for CloudWatch metrics, we have a number of metrics that we capture by default for Lambda and API Gateway. 6 for Lambda, 7 for API Gateway. We're always looking at more that we can add and kind of what value that gives our customers. And then for CloudWatch logs, for those of you who use Lambda today, you know that it's very easy to do things like a console.log and output information to CloudWatch logs. API Gateway gives you a number of different ways to capture logs as well, including you giving the ability to capture actually full method request and body content, which can be really useful for troubleshooting. And then the last bit down here, which is really interesting that people don't, I think, know enough about, is that there's this concept of log pivots in CloudWatch. And what this is you can basically apply regex to a log line, grab a data point, generate a graph from that. And now what you could do is things like percentiles inside of CloudWatch metrics, set alarms on those. And so you can actually see what your average is, your TP 75, 80, 85, 90, 95, 99, and understand kind of where your performance lies across that spectrum. That could be really key and or important, especially when people say things like, things seem slow. Well, what is slow? Well, for what percentage of our users? A little earlier today, Randall Hunt from our evangelist team talked a bit about Xray. What Xray does, it is not an APM tool. So application profile and monitoring tools like a Datadog, a New Relic, a Dynatrace, those are much more sophisticated tools, and actually almost all of them now or will soon have some ability to consume Xray. So Xray is not a competitor to those tools, it's a feeder for those tools. What Xray does is gives you the ability to capture information about what's going on inside your code. This could be Lambda, ECS, EC2, technically anywhere that you run code, you can tool Lambda and Xray into it. It gathers information about your application in the form of what are called traces, records those traces, and then makes that information available to you. And so you could do this yourself with really verbose logging and metrics collection, but use a tool like Xray, it's going to make your life a lot easier. So we can see here, I'll try this highlighting thing again. Awesome. What I'm doing here is I am including the Xray core SDK. I'm then wrapping the AWS SDK inside of the Xray capture call. And then what I have is just a very basic Lambda function that talks to S3. So it's going to put a key into S3 with a body of hello. And there we go. There's my S3 put object. Now inside of Lambda, or sorry, inside of Xray, what this will look like is this. And so what I see here at the top where it says AWS : Lambda, that's actually the Lambda service starting up or invoking my function. Then I can see my function information, and then I can see my call to S3. Now, had there been issues with this, or was I actually doing it at some sort of real-world volume, I would see a lot more information about the requests, whether they were failing, whether they were timing out, whether there were errors in them, heuristics basically in a diagram of the performance and stuff. I could also do things like dive into kind of the waterfall for this. So for a much more sophisticated application, this is actually really, really powerful. What is my Lambda function doing inside of its calls? Xray can help figure this out. And so I very, very regularly will talk to Lambda customers, and they come to me and they say, how do I figure out what's going wrong with my Lambda function? Well, it's using all the tools that I just mentioned. They're there, they're built in for you, they're very tightly ingrained and tied into the platform, and you can very, very quickly turn them on, tweak them a little bit, and start gathering information. So if you haven't looked at Xray yet, take a look at Xray. It's really, really pretty awesome. A lot of different capabilities inside of it. You can actually wrap individual functions or individual calls inside of your code in Xray and get lots of detailed information from it. Don't underestimate the power of logging in Lambda. So it's really basic. You can console.log whatever in the world you want, and it's going to get captured and shown in the CloudWatch logs interface. So for the kind of cheesy debug some message type outputs that you would typically do if you were developing an application, where you would turn that off in production, guess what? You can leave it on in production in Lambda. No end customer will hopefully ever see that because console.log is only captured by the underlying platform. So you can keep debug messages on, you can capture all sorts of things. And I typically find when customers are concerned about performance of functions, it's a lot of looking at information that could be captured by logs. And then lastly, when it comes to thinking about metrics, one thing that people will do is they say, oh, the built-in CloudWatch metrics, they don't give me enough information. Yeah, that's absolutely true. Create custom ones, especially ones that are more business-centric. An example of this, I had a customer that was processing data off of a Kinesis stream, and what they were struggling with is sometimes their Lambda functions would time out. And we said, okay, well, what is your average Lambda function doing that's processing data from the stream? They said, we have no idea. And so we said, okay, let's turn on some logging, let's turn on some Xray, let's see what's going on. And they found under peak load for their application, basically they were collecting beacons from similar to like an advertising service, if you will. Under peak load, Kinesis batches up messages, or the client batches up messages, and then Kinesis itself batches up messages. And when Lambda was processing it, it was unpacking all of that, and some Lambda function executions could try to process several hundred messages inside of that. Some would only process a couple dozen. And so when you had that several hundred, the time that it took to get through all of those would cause the function to time out. So we figured this out by just creating a simple CloudWatch log entry that basically put out, okay, how many messages am I processing from Kinesis in this individual invocation? It right away highlighted what they had to do to fix it, which was add more streams to Kinesis, and on they went. So we're going to talk about a couple of best practices that are a bit more general for serverless applications, not tied necessarily to the things that I've talked about so far here. The first is this concept of what I like to call Lambda-based monoliths. This is the idea, especially with things like API Gateway, where you have a single API gateway, you've got many API calls, and you're going to put all those things inside of a Lambda function because it's nice and easy and simple. This is a horrible idea. You do not want to put all of those methods and entry points into your API inside of a single function. And so while Randall said that we shouldn't use this word, I actually use it pretty regularly. Sorry, Randall. But this concept of nano services. And basically what you have with Lambda functions is, for many of our customers, even internally at Amazon, they're typically in the tens to low hundreds of lines of code compared to what I see with typical microservice-based architectures where you're maybe in the high hundreds to thousands of lines of code, compared to monoliths, which are in the tens or hundreds of thousands of lines of code. You really want to have really small functions. It really plays into the overall performance of your application, as well as kind of the general management and developer lifecycle of working with Lambda. So basic kind of rule of thumb for this is, unless your functions share a handler, split them into their own Lambda functions files or binaries. Another option here is obviously to make use of language-specific packages, so npm, pip, Maven, NuGet for C#. Don't want to have duplication of code inside of your code. Obviously, that's a very bad practice. And then unless if your Lambda functions don't even share event sources, don't put them in the same repository, don't put them in the same template, break them completely out. So if you have code that gets invocated by Kinesis and you have code that gets invocated by S3, maybe there's some business logic shared between them. Those are two separate applications. They consume a shared library. Break them up, treat them independent. Don't make them be the same thing. And then lastly, if you are using tools like SAM or CloudFormation to deploy your code, always validate that YAML, typically locally and then in your CI before you go to the back end. CloudFormation is kind of a very specific tool. It's not going to initially always catch everything that you're doing that's improper. And so with SAM local now, we have kind of a more advanced validate command. But even just a basic JSON lint or YAML lint is actually really, really powerful. So talking about compute power here. So with Lambda, for those of you who have used it, you know that you kind of have a single knob to turn for performance. And that's the amount of memory that you give your function. Well, actually, what we do is we actually proportionally give you a certain amount of CPU or networking capability to that Lambda function. So crank that knob up, you get more CPU and more networking. Pretty straightforward. However, what people don't expect is that by turning up that memory number and getting that CPU, even though it technically costs more as you're running the function, it doesn't mean that you overall are going to pay more for it. So in examples where your functions are much more CPU intense, so if you're doing machine learning, you're doing some sort of hardcore batch processing, maybe you're doing image transforms, or you're doing video rendering type things, what we've actually seen is that more memory is actually cheaper than less memory because you're going to get it done much, much faster. And so this is kind of a canned example here where we calculated over 1,000 times all the prime numbers less than 1,000,000. And what you see here is just between 128 and 1024 that the timing obviously went way down. I mean, to the point where you're almost at 1/10 of the time by multiplying the memory by 10. And the price is actually just a little bit more. And so this could be one of those things that people miss, especially when they're thinking about performance of their Lambda functions. Often say, well, how much memory did you configure for it? And everyone likes to stick with the default of 128 because it's the cheapest. But again, it may not be the most efficient versus that cost given the fact that CPU isn't aligned the same way. So if you've got functions, try cranking the CPU up, seeing what happens, looking at the duration of that function and seeing how that would play into the cost impact. Okay, how many of you have heard of cold starts before? How many of you have spent way too much time thinking about cold starts with your Lambda functions? A couple of people. Cool. So cold starts, this is one of the most, I think, kind of over worried about thing when it comes to Lambda and serverless next to the ghost of lock-in, which I don't talk about in my slides here today, but is also a fake thing to worry about. So with cold starts, basically the story is when you have a function that's invoked, basically there's no compute infrastructure that exists for the first invocation of it. And so what we have to do is take compute resources, align them with your account, pull down the code, run that code inside of a container on the host. This is kind of a low-level operating system container, and then invoke your function. So the first time that this has to happen on an individual host, it can take a little longer because we have to do basically all of the steps that I mentioned here up until we get to the green where we start your code. Now, after that container is up and running, it's considered warm. And so subsequent invocations of your function will typically go to a warmed function if one exists. Now, across all of Lambda globally, cold starts are less than 0.25% of all invocations. So millions and millions and millions and millions of invocations, less than 1/4 of them are actually impacted by cold starts. So what that means is that all the rest of them are landing on warm containers. So you don't want to think too hard and worry too much about this, but there are some best practices that you can follow to help even reduce your cold start penalties further. So one is to separate business logic from function signature. Basically, you have your handler in Lambda, pull all your active work that you need to do, your actual business logic, outside of that handler. Now, why is this important? Sometimes you could be doing things, and actually I'll talk about this a little more on the next slide, such as creating clients to services, for example, things like connecting to database backends, loading up variables like kind of global variables. Another is that the handler is basically always more or less going to be pulled into memory. And so the more stuff that you have inside of your handler, the more that you're putting effectively work on the underlying host that's doing stuff. So by pulling that functionality out, and then maybe it's usage specific or case specific, you can actually kind of streamline your functions a little bit. So I was just mentioning things that load into global scope, or say connections that you need to make to databases. If you do those outside of your handler, that will always happen during that cold start time. And then ideally when you're warm, you no longer have to do that. So that's another way to speed up your Lambda functions a bit. So we see here an example where I'm going to connect to S3, I'm going to connect to my database, and then potentially check inside of my handler if I'm not connected to reconnect, but ideally that shouldn't happen too often. So again, cold starts, ways to minimize them, but again, not the big boogeyman that everyone makes them out to be. Now, one thing you do want to think about is if you run your code inside of a VPC. So VPC, or Virtual Private Cloud, is a networking construct that we have here at AWS. And so when you run your Lambda function inside of a VPC, what we have to do is, once we've gotten that host for you that runs your functions on it, we have to create and attach what's called an elastic network interface. And this allows your functions to talk to the network inside of a VPC. Now, you should only ever launch your resources inside of a VPC if you need to talk to something else that exists inside of that VPC. By default, we run Lambda functions in a more or less secure networking way. There's no way to connect to them over the network. There's no such thing as SSH into a Lambda function, or pinging a Lambda function, or port scanning a Lambda function. It just doesn't exist. And so from a network security standpoint, you don't ever have to think about that, again, unless you want to put them into your network. Even in this model, there's still no way to really port scan a Lambda function. You're not going to get anything interesting out of it. But again, if you don't need a VPC, don't use a VPC. Another way to think of it is kind of a very simple logic diagram here. Should my Lambda function be inside of a VPC? Well, again, do I need to talk to anything inside of a VPC? No? Great. Don't use a VPC. Yes. Okay. Does my function need to talk to something also potentially public on the internet and something inside of my VPC, which is not necessarily a good practice? You should typically break that business logic into two different functions. But if this is the case, then what you need to do is have some sort of NAT gateway, whether it be our NAT gateway or some sort of other proxy that you run that can be used as a gateway, enabled. So there is no way to put a public IP on a Lambda function today, and so that is kind of a requirement. So again, this is one of the other things that will impact a cold start, but once your function is up and warm, not something you really need to worry about. So let's say that you're still really paranoid about cold starts. You have a really infrequently used Lambda function, and so you could potentially be expiring out your compute infrastructure behind the scenes. Another option that people do, and I really call this a hack, is basically set up a scheduled cron job using CloudWatch scheduled events to run some sort of ping logic that will basically invoke your Lambda function for you. Now, one common mistake that people make is they will actually invoke the actual service via its invocation model. So they will call API gateway, or they will call Kinesis, or they'll put a fake object in S3. Don't do that, because you're just wasting money on something that you shouldn't. So you can directly invoke Lambda functions via API. You can pass in a somewhat contrived payload that basically says, hey, this is a scheduled payload. It's got some nonsense for ping. Inside of your Lambda function, have a function inside of your code base that handles this, again, outside of your handler, and use this to keep your functions warm. And basically, the rough rule of thumb is you want to do this every 5 minutes for functions that are outside of VPC, and roughly every 15 minutes for functions that are inside VPC. Now, we don't officially document this because at the end of the day, we're doing a ton of really hardcore stuff to try to remove cold starts from being a problem inside of Lambda. And we also do a lot of stuff to tune how long we keep warm instances around. So we don't have a real formal guidance on this. It's shifting. It shifts under a lot of different things. It's fairly variable. But the 5-15 rule works out pretty well. And again, if you really are concerned about cold starts and you actually have seen evidence of them, then the CloudWatch hack can work. So we've covered a whole lot of different stuff today between kind of CI and CD best practices, environmental best practices, variables, things like parameter store, when to use multiple stacks, when to use multiple accounts, when not to, performance tuning in terms of things like, again, CPU, more memory equals more CPU, more networking, where you should put your code inside of your function, invoking things outside of your function, and how to do kind of monitoring metrics and logging. The great news is that if you forgot something that I said today, you can read all about it on this page. So AWS, Amazon.com/serverless, kind of our key landing page. We've actually got a lot of content that's going on this real soon in terms of other talks and our key blog posts and stuff like that. We recently, just in September, launched a subpage off of this for developer tools. So kind of all the key frameworks that we see our customers using are mentioned off of here. All of our CI and CD tools, documentation for things like SAM and so forth. And so you can really kind of dig in pretty deep. Again, my name's Chris Munns. I'm Senior Developer Advocate for Serverless at AWS. Really thank you for coming to this talk. Hopefully you've had a chance to learn something. Thank you to the folks from Devoxx for having me. This is a really cool event. I'll be sticking around out in the hallway here for questions, and I'll see you around. Feel free to reach out if you have ever any questions about Lambda, Serverless, anything at AWS. Feel free to yell at me on Twitter. I'm happy to respond. And thank you very much.